So now this video discusses about what we call as the complex numbers, and where we should have the basis of the complex numbers. We should have to understand about the imaginary unit, and we should also have to understand about the operations behind the complex numbers, that is addition, subtraction, multiplication, as well as the division. We should have to understand about the conjugate of the complex numbers, and from there we should have to simplify the expressions, algebraic expressions, to do with our complex numbers. Of course, later on we should have to discuss about solving equations that involves the imaginary unit. So that's how we should have that understood. Now, in order to understand about the complex numbers, we need to have to understand or remind ourselves about the polar coordinate system as well as the rectangular coordinate system. And from there, we should have to map forward. Now, let's say we have this is a two-dimensional Cartesian plane. Let's say this is a two-dimensional Cartesian plane. Let's say that is the case. And thus we should have to understand that this is a y-axis and this is the x-axis. And now let's say we have some point. Let's say we have it as a point P on a plane. Let's say the coordinates corresponding to point P are given as, let's say, x, and by the way I should have this. Let's say that is the point P I should have. And now let's say the coordinates corresponding to the point P are given as, let's say this is the x and say this is y. Let's consider the case being given as that. And now for this case, what are the coordinates corresponding to the point P? The coordinates corresponding to the point P are given as, x, comma y, and this is what we call as the rectangular coordinate system. Should be the rectangular coordinate system. Rectangular coordinate system, and that is given as, x, comma y. And now let's think of having the distance from the origin to the point B. Let's say that is the case. And now the distance is given as should be L. That should be R. That corresponds to the distance from the origin to some point B in that case. Using the distance formula, the distance R, from the fact that the origin is given as L, L, and the distance R is given as the square of should be x squared and plus y squared. That's how we should have the distance formula, and that's from the origin to some point P in that case. And what else should you have to decide about? And now let's think of having the angle from the positive x-axis to the from the positive x-axis to the a line drawn from the origin to the point P. That should be this angle. Let's say this angle is given as should be theta. And how do you think we should have the expression for the angle theta? Now let's think of completing the should be the right angle triangle. And now this is a right angle triangle, and you also can do the same with this point for you to have the full overview on what is happening. Of course, for this case, what it does is that this angle theta is the same as this angle theta, of course, but let's just have to use this triangle instead of using the other case. And as you can see, this side is the same as this side, and therefore the length of this side will be given as y, and the length of this side is given as x, as we have it there. That should be given as that. And now using the trigonometric ratios, that is the opposite adjacent, and thus corresponds to have it as a tan. And therefore relationship that expresses the angle theta and the other two sides is expressed using the trigonometric ratio that is tan. So we should have it as tan theta, and which is equal to opposite adjacent. Thus we should have it as y of x. So it should be that, which means in all cases what it does is that angle theta is given as the tan inverse of y over x. We can have it as that. So angle theta is given as tan inverse of y over x. So that's I can have it as that. So now using the angle as well as the distance from the origin to some point B, then we can be able to express another way of giving out the location of the point B. And what is that one? We call it as the polar coordinate system, and that should be given as r, theta. So that's the point B can also be expressed in terms of the polar coordinate system, which is given as r, theta, of which r is calculated using this formula, and theta is calculated using this formula. And whereas x is given as using the trigonometric ratio, and since we have the hypotenuse which is given as r, then the x should be the x is given as the adjacent hypotenuse. And what is that? And that is should be cos x is given as should be r cos theta, and that of y is given as r sin theta. I understand what is should be how we can have to resolve r into components using the trigonometric ratios. So this is the overall conclusion that you can have. Let's say we have a point B with a rectangular coordinate system given as that of x, y. In terms of the polar coordinate system, a point B is given as r, theta, and of which r is given as should be square root of x squared and plus y squared, and whereas x is given as r cos theta and y is given as r sin theta, like that. And theta is given as the tan inverse of should be that of y over x. So that's how we should have it. So this is what they call as the rectangular coordinate system, and this is what they call as the polar coordinate system. And these are actually their basic formulas we should have. So which means, let's say we have a point, let's say a point M with the rectangular coordinate system given as 2, 5. So we should have a point M in terms of the polar coordinate system. What it does is that the x is given as 2 and the y is given as 5. So in order to have M in terms of the actually a polar coordinate system, it means the M will be expressed as the r, theta, of which r corresponds to have it as the square root of x squared, y squared, and we should have to work it out there. Thus we should have a sum at about we should have it as 2 to the power 2, that is 4, and 5 to the power 2, that is 25. So which means we should have it as the square root of 29, and that is the value of r. And from there we should have the value of the angle theta. And what is that? Angle theta is given as the tan inverse of the 5 over 2. And what should be that? Angle theta will be given as, thus we should have the tan inverse of 5 should be over 2, and thus we should have it as 68.2. That should be just 68.2 degrees, and therefore the point M in terms of the polar coordinate system will now be given as square root of 29, square root of 29 and 68.2 degrees. So that's how we should have it. And also try to have this at your own time. Let's say if we have a point B with the rectangular coordinate system given as, let's say, 5, 12, we should have that. And let's say point O is given as, let's say, negative 6, should be 7. And let's say we have a point X which is given as, let's say, negative 20, and say that should be 30. We should have these points in terms of the polar coordinate system. And how about if we have the polar coordinate system and we should have that on the rectangular coordinate system? And now what it does is that, let's say if we have a point B which is given as 5, let's say 30 degrees. How should you have this in terms of the rectangular coordinate system? What it does is that we should have it as a point B being given as x, y, and of which x has to be given as r cos theta, and the y has to be given as r sin theta. We should have that. And now, based on the given information, r corresponds to have it as 5, and theta corresponds to have it as 30. Therefore, we should have to simply substitute x is given as, what is r? That is 5 cos of 30 degrees. Should be that, and which is given as 5 times cos 30. That's simply should have it as 4.3. And how about y? We should have it as 5 sin 30 degrees, and we should have it as 5 times that of sin 30 degrees. Should be 5 times sin 30 degrees, and what should have is, that's 2.5, like that. Therefore, the point B will not be given as, so we always start with the x coordinate 4.3 and comma 2.5. So that's how we can have the point B in terms of, in terms of what you get as the rectangular coordinate system. And in some cases, you can also have the case like this. Let's say if we have, a point B as well, which is given as 10, let's say pi over 6. How do you think we should have this? It's just that the angle has been expressed in terms of the last part. We should have it in the same as well, where if you may wish, you should have to express this angle in terms of the degree measure, then you have everything out in the right order. But everything in all cases principle remains the same. R is given as, should be 10, and the theta is given as pi over 6. Of which, if you may wish, you have it as 180 degrees divided by 6. And thus we should have, so simply, the angle theta is given as 30 degrees, so which is the same as having it as, a point B being given as 10, 30 degrees, and take it from here the way we have recently discussed about this. And at your own time, try to have also the following cases. Let's say we have a point N, and which is given as, let's say 2, let's say 3 pi over 4. Try to have this out. Let's say we have a point M, and which is, let's say, should be 7, let's say 70 degrees. We should have that one. Let's say if we have a point B as well, and which is given as 15, let's say should be 180 degrees. Better it should have 18 degrees rather. So try to express this in terms of the rectangular coordinate system. It should be that. And now the point of interest is, what is our complex number? So how do you think the complex number is all about? Let's say we have a point, let's say we have a point B. In terms of the rectangular coordinate system, should be in terms of the polar coordinate system is given as r, theta. Let's say that is the case. But now, of which r is given as, should be of which, should be, let me have this. Let's say we have a point B. In terms of the polar coordinate system is given as r, theta. Of which, in terms of the rectangular coordinate system, a point B is given as x, y. We should have that as that. But now, this is what you get as the rectangular coordinate system. Assuming that, x, y is now being expressed as, let's say, some number given as 8, and which is equal to, x, y, of which you can also have it as in the same way, which is the same as, z is equal to x plus y. It is the same way you can have to express that as that. But now on the same case, z can also be given as x plus yi, of which I is known as the imaginary number unit. So we call it as the imaginary number. We call it as the imaginary unit number, or simply imaginary number. So imaginary unit number, that's what they call it as the I. So which means now for this case, what it does is that the z, what it does is that the z is said to be the complex number. So which means a complex number can be a number. Let's say if we have m is the same as 2 plus, let's say, 5i. This is what we call as the complex number. And let's say we have a p can be given as, let's say, negative 5 plus, let's say, 4i. That is the complex number. So we should have that, where I corresponds to the imaginary unit number. So we should have that. And we can also have, let's say, somewhat about, let's say, a point O can also be given as, let's say, negative 5 plus, let's say, 20i. You can have that as that, where we should have to multiply imaginary unit number to only y component of the given point. Let's say we have this kind of a case. We have, let's say, a point M. In terms of the rectangular, should be a polar coordinate system. We have, let's say, 6, should be 20 degrees. So we should have to express this in terms of the complex number. So how do you think we should have that understand? In terms of the complex number, we should have to understand that the m has to be expressed as, should be x plus yi, of which x is given as r cos theta and y is given as r sin theta. And what is x? We should have it as, should be 6 times cos of 20 degrees, and thus we should have it as 6 times cos 20, and we should have it as 5.6. And y has to be given as, should be r sin theta, that is 6 times sine 20 degrees, that should be given as 2.1. And therefore, m as the complex number will now be given as, should be somewhat about 5.6 and plus 2.1 I, and this is how we should have it in terms of the complex number. We should have that. And let's say if we have, let's say, some point equated as, let's say, a point V, and thus in terms of the rectangular polar coordinate system is given as, let's say, should be a 9, let's say 69 degrees. So in terms of the actually a complex number, the same case can also be given as, the same case can also be given in the same way. V is given as, should be, is given as x and plus y I for that case, and where x corresponds to have it as r cos theta, and thus we should have it as 9 cos of 69 degrees. And what would be that? So as you can see there, we'll have it as 9 cos of 69 degrees. That's 9 times cos of 69 degrees. And thus we should have it as 3.2. And we should have it as y, which is given as r sine 69 degrees as well. And which is given as, should be 9 times sine of 69 degrees. And thus we should have it as 8.4. As that. And therefore, the v in terms of the complex number will now be given as 3.2 and plus 8.4 I. So that's how we can have it in that way. So what if we have been given just the rectangular coordinate system? How can you have the complex number for that? Let's say we have a point M, and which is given as, let's say, x, y, and simply the complex number corresponding to the point M, that can be given as x plus, yi, without the need of having going over the way I've recently discussed. In the sense that, let's say we have a point M, which is given as 2 comma 5 comma negative 5. Simply this is the same as having it as 2 minus 5i. That's the same as that. And let's say on the same case, if we have, let's say, a point, let's say w, and which is let's say a point w which is half, comma negative, let's say half. Simply this is the same as having it as half minus half should be I. So you can have it as that. So actually a difference basically in electric system should be in electric system or the electric difference. Instead of having I, they represents with what we call as the J. Hence, they are known as the J operators. So in all cases, it remains the same. In an electric system, instead of using I, they use what we call as the J. Hence, they call it as the J operators. But principle remains the same. So keep that in mind. So according to the principles behind the imaginary unit number, if we have a J square, this is the same as the negative 1. So if we have the J square, this is the same as the negative 1. And now for this case, J corresponds to have it as the negative, should be square root of negative. So having J, it means this is the same as the square root of negative 1. So now from this analogy, now we can be able to, let's say, solve the equations that involves the negative number. It should be the square root of negative number. So we can be able to solve, the equations that involves having the roots of the square root of whichever the negative number that we came across with. From this analogy, what it tells us that if we have, let's say, square root of negative 5, this is the same as having it as the negative. It should be square root of negative 1 times positive 5. That is the same as that. We just have to separate using the brackets for you to have the full insight. For this case, this is the same as having it as the square root of negative 1 times the square root of 5. Now what is the square root of negative 1? That is the same as J. And therefore, what it tells us that should be that is the same as I, not J. And therefore, we should have, somewhere about I square root of 5. So that is the same as that. And also if we have, let's say, should be square root of, let's say, negative, let's say 10. This is the same as having it as the square root of negative 1 times square root of 10. And of which this is the same as I times the square root of 10. It is the same as that. So which means by now we can be able to express the operation to do with should be that of the square root of any negative number that we may think to come across with. So that's the basic idea behind. So how can you have the operations to do with the complex numbers? So first of all, let's see how we can be able to add or subtract the complex numbers and appreciate that. Let's say if we have a complex number given as, let's say, a z, and which is given as a plus should be, let's say, which is given as a plus ib. Of course, you can also have it as a bi or ib. That is the same as that. And we have the complex number which is given as, let's say, should be w, and which is given as, let's say, a c plus should be somewhat about, let's say, id. Now, how can you be able to add the two complex numbers? If that is the case, z plus y, actually z plus w, this is the same as having it as a plus c and the plus b I plus di, of which this is the same as a plus c and plus b plus d outside that one. So that's how you can have it as that. Or else, if you wish to subtract the two complex numbers, what it does is that we should have it as, a minus c, like that, and plus that should be given as should be about bi minus di, and which is the same as having it as a minus c and plus that of b minus di outside. So that's how you can have it. So let's see how we can have the following cases and see how we can have everything. Let's say if we have the complex number a, which is given as 2 plus, let's say, 3i, and the complex number b, which is given as 9 should be 9 minus 4i. And now we should have a minus b. How do you think we should have that on? For this case, what it does is that we should have to subtract these actual numbers, that is should be 2 minus 9. We should have it as that plus, then we should have it as should be a 3i minus and minus 4i, and which is the same as we should have it as should be negative 7, and what is that? We should have it as the positive, should be positive 7i. So that's how we should have it. And on the same case, how do you think if we wanna have to add that on? Now if we are to add, what it does is that we should have to add them in the sense that we should have it as 11, and what is the addition for this? That's given us the negative should be a 1i, which is the same as 11 minus should be I. We should have it as that. And how about, let's say if we have a case being given us this, and what if, let's say we have a complex number z, which is given us, let's say, 5 minus 6i, and we have it as the w, which is given us 2 should be 9 plus, let's say, 2i. So how should you have, let's say, z minus w? Principal means the same. We should have it as 5 minus 9, let's say somewhere about like that, and we should also have it as a plus, then we should have it as negative 6 minus 2, and thus we should have it as, and thus we should have something about negative 4, and should be negative, by the way, we should have it as negative 8i. So that's how we should have it. Or simply what it does is that having the case like this, that is the same as having it as 5 minus 6i, and minus what is w, that is 9 plus 2i. If we should have to distribute negative, then we should have it as 5 minus 6i, and that's negative 9 negative 2i, which is the same as we should have to correct the like terms. Thus we should have it as it should be negative 4, and thus we should have it as negative 8i. So that's the principle behind the addition as well as the subtraction of the complex numbers. And also in the same case, what if, let's say we have a case like this? We have a complex number a, which is given as 3 minus 4i, and let's say if we have it as a complex number b, which is given as 5 plus i. So how do you think we should have to add or subtract this? Try to have to work it out on your own for that way. And how about the multiplication of the complex numbers? Assuming, let's say we have a complex number a, which is I should have to use this. Let's say we have a complex number, let's say x, and which is given as a plus bi, and we have the complex number a, which is given as, let's say, m plus, let's say, ni. The product of these two complex numbers is given as xy, and what would be that? This is the same as having it as a plus bi in times m plus ni, of which this is the same as having it as m times m, that is am, and also that of should be a times ni, actually a times ni, that is the same as a ni, and we should have it as, should be bi times m, that is the same as mbi, and thus we should have it as, should be nbi square. So that's how we should have to understand about the multiplication of the complex number. It is the same way we have to understand about, it is the same way we understood about actually multiplying the binomial expressions, like that. Or else you can also use what you get as you can also use what you get as the Crumb method of multiplying algebraic expressions. If you want to have the detailed structure about this technique, just have to refer to my videos on YouTube channel, GB Analytical School of Science, a Crumb method of multiplying algebraic expressions. You have this typical beautiful technique, and thus we should have it as, xy is given as a times m plus, should be m plus ni, that should be plus by, should be bi, that's times m plus ni. Or else you can have it in the same way, which is given as m times a plus bi, and that of plus ni, and times a plus bi. I can have it as that, which is the same as ma plus mbi, and that's of plus ani and plus bni square. Thus we can have it as that. So keep that in. As you can see, what we have it here, it is the same way what we have obtained here. So that's the beauty of it. And also on the same case, let's say, how can you have the scalar product of the complex numbers? Let's say if we have a complex number a, which is given as, should be a complex number, let's say x. Let's say I have a complex number x, which is given as a plus bi. And now if we have a scalar value, let's say given as, it should be k, xk, this is the same as having it as, should be k times a plus bi, and which is the same as ka and plus kbi. It is the same as that. In other words, if we have the scalar product of the complex number, that corresponds to have to multiply the scalar value onto whichever the value we have in a given complex number. So we should have that. Let's say if we have the complex number as x, which is given as 2 minus, let's say 5i, and y is given as, let's say 3 plus, let's say 2i. So how do you think we should have the product of the two complex numbers? Principle remains the same. That's 2 minus 5i and times 3 plus 2i, like that. And now for this case, we should have 2 times 6, that 2 times 3, that is 6, and 2 times 2i, that is 4i, and negative 5i times 3, that is negative 15i, and negative 5i times 2i, that is negative 10i squared. This is the same as, we should have the like terms, and these are the like terms that we should have it as 6 and minus 11i, and what is should be I to the power 2, that is negative 1. So we should have it as negative 10 times negative 1. Thus we should have it as 6 minus 11i and plus 10, of which these are the like terms. We should have it as 16 minus 11i. So that's how we should have it. And even using that of the column method of multiplying the algebraic expressions, we also have the same way. That is should be 2 times 3 plus 2i. We can have it as that negative 5i, and times 3 plus 2i. You can have it as that, which is the same as 2 times 2, that is 2 2 times 3, that is 6, and 2 times 2i, that is plus 4i. Negative 5i times 3, that is negative 15i. Now we should have it as negative 10i squared. And now this we should have it as negative 11i. That should be given as 6 minus 11i, and 10 times negative 1. Which is the same as, we should have it as a plus 16 and minus 11i. So that's how you can have it as that. And now let's say if we have a case like this. Let's say if we have the complex numbers a, which is given as, let's say, should be 6 minus, let's say, 4i, and b, which is given as, let's say, 2 plus, let's say, 2i. Now we should have the following operations, that is, let's say, 2a times, let's say, 3b. How do you think we should have this? What it tells us that we should have it as, what is 2a? 2a corresponds to have it as 2 times, what is a complex number a, 6 minus 4i, like that. And that is given as 12 minus 8i. And what is 3b? We should have it as 3 times 2 plus 2i, and thus we should have it as 6 and plus 6i. And from there we should have to multiply the two expressions, then have it out there. And now what if we have a complex number, let's say m, which is given as, let's say, 6i, and we have the complex number n, which is given as, let's say, should be a 7 minus, let's say, 2i. So how do you think we should have the product of this? As it stands here, as you can see, we are writing another part of the expression, which is the same as having it as, this is the same as having it as 0 plus 6i. And from that point, it means we have this part, which is said to be the little valued part, and this is imaginary part. So whatever the part which is lacking, indicate that as 0, then you should have the proper operations from that point. And now let's see how we can be able to divide the complex numbers. So how do you think the division of the complex numbers can be done? In order to understand about the division of the complex numbers, we should have to understand about the conjugate of the complex numbers. If we have the complex number a, which is, let me use it as x, not a. If we have the complex number x, which is given as a plus bi, the conjugate of the complex number x is given as x bar, which is given as a minus, bi. We multiply negative to the imaginary part. In the same case, let's say if we have a complex number m, which is given as 2 plus, let's say, 5j, its conjugate will be given as 2 minus 5i. If we have, let's say, the complex number y, which is given as the 5 minus, let's say, 4i, its conjugate is given as 5 plus 4i. We should have it as that. So that's the basic idea behind that one. So how should you have the division of the complex numbers? Let's say we have two complex numbers, let's say x, which is given as a plus bi, and we have the complex number y, which is given as, let's say, m plus ni. The division of the two complex numbers is also being said to be the quotient, that is quotient x over y. This is the same as having it as x divided by y times the conjugate of the denominator, and which is given as y bar over y bar. So that's how we have to operate the conjugate, should be the division of the complex numbers. Let's say if we have the two complex numbers given as x is equal to 2 minus 3i, and y is equal, let's say, negative 3 plus, let's say, 4i. The division of the two expressions, that is x over y, this is the same as 2 minus 3i over negative 3 plus 4i. You know, having that expression, this is the same as having it as 2 minus 3i divided by negative 3 plus 4i in times the conjugate of the denominator, which is negative 3 minus 4i, and divided by negative 3 minus 4i. And from there we should have this expression, and thus we should have it as 2 minus 3i n times negative 3 minus 4i, and divide by, thus we should have it as negative 3 plus 4i n times negative 3 and minus 4i. So let's see how we can be able to simplify that expression. And according to what we have recently discussed about on the the multiplication of the complex numbers, what it tells is that we should have 2 times negative 3, that is negative 6, and that's negative 8i, and that's positive 9i, and should have it as a 12i square, and that's divided by, it also principally means the same, that is been given as the 9, and we should have it as, should be positive 12i, and also we should have this is the negative 12i, and thus we should have it as negative 16i squared, which is the same as, these are the like terms, and that should be given as negative 6, and thus we have it as plus I. And what is this? That's negative 12. So have it as negative 12 divided by, and now we should have, this is L, we should have it as 9, and this is negative 1. Negative 1 times negative 16, that is positive 16. We should have it as a positive 16, and therefore we should have it as, and what is this? That is negative 18 and plus I, and which is divided by, and what is that? So 9 plus 16, that is 25. It should be 9 plus 16. 9 plus 16, that is really 25. So have it as over 25. Which is the same as having it as 18, negative 18 over 25, and plus I over 25, of which this is the same as having it as negative 18 over 25 and plus 1 over 25 times I. That is the same as that. So that's the basic idea behind the division of the complex numbers. And what if, let's say, we have the case being given, let's say 2 plus, let's say, 4i, and which is divided by, let's say, 3 plus, let's say, 10i. Principally means the same. We should have it as 2 plus 4i divided by 3 plus 10i times the conjugate of the denominator, which is given as 3 plus, should be minus 3 minus 10i divided by 3 minus 10i, and thus we should have the expression being given as 2 plus 4i and times 3 minus 10i, and which is divided by 3 plus 10i and times 3 minus 10i. We should have it as that, and from there we should have to simplify the expression like the way we have recently talked about, as that. And what if, let's say, we have a case like this? Let's say we have 3 minus, let's say, 4i, and divided by, let's say, 5 plus, should be I. We should have to simplify that one. And let's say if we have, should be 5 plus I divided by, let's say, 3 minus 4i, and try to have that one as well. And say, what if, let's say, I have a negative 1 plus 3i divided by 2 plus 7i, try to have that one. And let's say if we have 1 over, let's say, 2 plus 3i, should have that one as well. And how about, let's say, if I have a case like this, how do you think we can have it? We have, let's say, a 3 plus a 2i, and divide by, let's say, 4 plus 3i, in times, let's say, 5 minus I divided by should be 4 minus 2i. So how do you think we should have this kind of expression? First thing, we should have to express this in terms of the division of the complex numbers. We should also have to express this one in terms of the division of the complex numbers. Then we should have to operate the product of the two. And think of this. Of course, we should also, first of all, we can also think of multiplying the denominators as well as the numerators, and thus we should have it as 2 plus 2i. It should be 3 plus 2i in times 5 minus I, and thus divide by 4 plus 3i times 4 minus 2i. We should have to multiply the actual expressions. Then from there we should have to do the division of the result, or else you may think of, but it is the same principle that you can have, but or else you may think of having the division of these two and also these two. Then you just have to simplify it out at the end. So that's how we start to understand that and start. And let us see how we can be able to simplify, the following. Let's say if we have 5i to the power 2. How do you think we should have to simplify this one? Principles actually remains the same. Having j square is actually having I square. It is the same as the -1. Hence, we should have it as a -5. And what if, let's say, we have a case like this? Let's say if we have a 6i to the power 3. So how do you think we start to simplify this? Having this case, this is the same as 6 times I to the power 2 and times I, of which that is the same as -6i. That is the same as that. And what if, let's say, we have a case like, let's say if we have, should be a 3i minus, let's say, 5i squared, and minus, let's say, I to the power 5. How do you think we should have to simplify this expression? We cannot simplify this to any expression that is given as 3i, and this is -1 times -5, that is +5. The minus, we should have it as, should be I to the power 4 and times I. That is the same as that. And from there, we have it as 3i plus 5, and this should also be expressed as, should be I to the power 2 in the overall to the power 2, or else you may think of having it as, I to the power 2 times I to the power 2 and times I. It is also the same as that, but let me just use this notation. And thus we should have it as I to the power 2 into over the power 2 minus I, of which this is the same as the -1. -1 to the power 2, that is +1. We should have it as 3i plus 5 and minus I. So from that point, then we can be able to have it as 5 minus 2i. So this is the actually answer for that. Now what if, let's say, we have this kind of expression? Let's say if we have I to the power, let's say, 20. So how do you think we should have to simplify this expression? For this case, we should have it as having it as I to the power 4 and times the power 5. I to the power 4 is the same as having it as, should be +1, because I to the power 4, that is the same as the power 2, and should be I to the power 2 over the power 2, and which is, this is the -1, and -1 times the power 2, that is the same as, that should be given as the +1. So in all cases, I to the power 4, that is the same as the, should be a +1, and therefore we should have it as 1 to the power 5, which is the same as 1. And what if, let's say, we have a case like this? What if we have I to the power, let's say, 26? So how do you think we should have to express this? For this case, what it does is that we should have it as I to the power 25 and times I. And what is 25? 25, that is the same as having it as I to the power of 4 times, should be 25. That should be given as this. And by the way, we should have this one as this. Okay, let's say we have the same actually I to the power 26. So I to the power, actually to the power 26 can be expressed as, I to the power should be 24 in times I to the power 2. We can have it as that. But 24 can be expressed as I to the power, there should be that of 4 times should be 6 in times I to the power 2, of which this is given as should be positive 1, and this is given as the negative 1. That is the same as 1 times negative 1. We should have it as the negative 1. So this is the expression, should be the solution. And what if we have, let's say, I to the power 36? How do you think we should have this? For this case, this is the same as having it as I to the power 4 and times 9 outside. And this is given as the positive 1. That should be given as 1 to the power 9, which is the same as 1. So that's how I can have it. What if we have it as I to the power 83? How do you think we should have this? Try to work it out on your own. Thus, and what if, let's say, we have should be I to the power 101? Try to have that one. What if, let's say, have I to the power should be 12? Try to have that one. And I to the power, let's say, should be 54. Try to have this one as well. Thus, at your own pace. And now try to simplify the following expressions. We have the negative square root of 49, and let's say plus square root of negative 9 plus square root of negative 4. So how do you think we should have to simplify this expression? First thing, we should have to understand that that is the same as having it as should be that is the same as having it as I times the square root of 49, and that is the same as I times the square root of 9 and plus I times the square root of 4. This is the same as 7I and plus 3I and plus 2I, and from there we can be able to add this expression. And let's say if we have a case like this, and let's say if we have 1 plus, let's say, square root of 36, and times this should be negative square root of 36 should be square root of negative 36 in times square root of negative 36. Principal means this the same. This is the same as 1 plus I times the square root of 36 and I times the square root of 36, and I that is I squared. And what you have, this is what is that? That is being given as should be square root of 36 times the square root of 36. That is given as times 36 as well. That is given as 1 plus 36I squared, and which is the same as 1 minus 36, and which is the same as negative should be that of 35. And since this is negative 1, that's negative 36 now. So that's how we can have to simplify that as that. And on the same case, the imaginary number can also be used to solve some sort of the equations that involves the negative square root of numbers. Let's say if we have should be square root of negative numbers. Let's say if we have x squared and minus x plus 1 is equal to 0. How do you think we should have we should have to solve for this equation, and thus should have to involve the square root of negative number. And let's think of using the quadratic formula. And thus we have a being given as 1, and b is given as the negative 1, and the c is given as the positive 1. And now for this case, x is given as negative b plus or minus the square root of b squared minus 4ac over divided by 2a. And thus you should have it as negative 1, negative, that is 1, plus or minus, b squared, that is 1, and 4 minus 4 times ac, that is minus 4, and divide by should be 2, and which is the same as 1 plus or minus the square of should be negative 3 divided by 2. And now from that point it means we have x is equal plus should be 1 plus square of negative 3 divided by 2. And what is this? That is the same as 1 plus I times the square of 3, and which is divided by 2. So that is the solution. And on the same case, x is given as 1 minus I square of 3 and divided by 2. That is the solution in terms of the imaginary number unit. Like that. And what if, let's say, we have it as 2z square and plus 3z, and that's what plus 4 is equal to 0. Principle remains the same, that you can have to work it out. And how do you think we should have to solve? Let's say if we have polynomial should be a cubic equation. Let's say if we have x cubed and the minus 3x squared and plus 4x minus 12 is equal to 0. So how do you think we should have to solve for this? By the way, it should be minus 12. Should be minus 12 is equal to 0. We can factorize this using the grouping technique. That is, should be the x squared, and that's x minus 3, and you should have it as 4, that is x minus 3, and which is equal to 0. And that's x minus 3 times x squared plus 4, and which is equal to 0. And therefore x minus 3 is equal to 0 using the 0 product theory of algebra, and x is equal to 3 for this case. On the same case, x squared plus 4 is equal to 0, and therefore x squared is equal should be negative 4. We should have to introduce square both sides plus or minus. It means we have x is equal to plus or minus the square root of negative 4. And for that case, what it does is that we should have it as x is equal positive square root of negative 4, which is the same as I times the square root of 4. And x is equal to negative square root of 4, which is the same as it should be negative I times the square root of 4. So these are the solutions that you can have, including x as 3. And what if, let's say, we have a case like this? That is, let's say x to the power 6 and minus 9x to the power 4 and plus, let's say, a 16x squared and minus 144 is equal to 0. Principle remains the same in the sense that we should have to factorize this using the grouping technique. That is x to the power 4, x2 minus 9, like that. And also plus should be somewhat about, should be 16 somewhere, and x squared minus 9, which is equal to 0, like that. And from there we should have x to the power 4, and thus plus 16 and times x squared minus 9 is equal to 0, and take it from here and see how you can have to solve for that. So that's the principle behind solving the equations that involves having the negative square of the negative numbers, and see how you can have it. And now at your own time, try to have the following as well. and thus we should have, let's say, x to the power 5 and plus 4x squared, and should be cube lather, and plus 8x squared and plus 32 is equal to 0. And try that on. Let's say 2x cubed and plus 4x squared, and that should be plus 3x and plus 6 is equal to 0. Try to have that on as well. And now here are some of the questions that you should also have to practice as well, far as the complex number is concerned. We should have to show that -1 plus I square of 3 over 2 and over the part 2 and plus -1 minus I square of 3 over should be over 2 and to the power 2 is equal to should be 1 in -1. We should have to show this if that is true. And we should also have to work out this. Assuming that z is equal to -1 plus I square of 3 and divided by 2, and the w is given as -1 minus, let's say, I square of 3 divided by, let's say, 2. We should have to verify if the following statements are true. Z cube is equal to 1. W cube is equal to 1. We should have to show if that is true. And Z is the same as W square. We should have to verify if that is true, and also W is equal to Z square. We should have to verify if that is true. And also in the same case, 1 minus Z and plus Z squared and times 1 plus Z and minus Z squared is equal to 4. We should have to verify if this is true or not. So try to practice such cases and appreciate your ability in case you have well understood the context or not. And let's say if we have A plus, let's say, BI over A minus, let's say, BI, and plus, let's say, A minus BI over, let's say, A plus BI. We should have to find the real and the imaginary part of this expression. So we should have the real as well as the imaginary part of this expression. So here is just something that can just have to help you. If we have the complex number, let's say A plus, let's say, BI, this is said to be the real part and this is said to be the imaginary part. So in the sense that looking at the expression that you are being given, we should have to express that one up to this far, and where we should have to identify what is the real part as well as the imaginary part. So try to work it out. These are just some questions that you should have to really work on as part of your practice. You should also have the real part as well as the imaginary part for this, and that's just have to see whether you are part of the game or not. But I understand what it means here, and you'll be able to work it out properly. You just have to try this to have the imaginary part as well as the real part and have it out. And I also have this question: find the real part of should be A plus BI to the power 2 and divided by A minus BI and minus A minus BI should be divided by somewhere about A plus BI. Try to have that one. We should have the real part as well as the imaginary part for that expression. So that's the basic idea behind the complex numbers.